Good afternoon, everyone. Welcome to the inaugural and hopefully one of the first of many, the art and science of application-aware network performance management. So it's a big mouthful, but it's a big subject. We can see that we've got two other dates other than this: the 11th of November, where we look at the flow to packet environment, but using LiveNX and also the LiveWire technology, so that'll be an interesting session. And then on the 9th of December, we'll be looking with using Omnipeek again to use to work with the Wi-Fi environment and such like. During the session, we will be taking questions, but they will have to be submitted using the questions section on the right-hand side. So if you can type in any questions you have, what we'll do is we'll answer those questions at the end. Apologize for that, but otherwise we'll end up going down a route and we want to stay focused on the demonstration and the presentation. So with that, the agenda is very quickly the introduction, which is only going to take 5 minutes. I've been told. I'm going to hand over in a second to Peter Provert, who is the EMEA and Russia Partner Alliance Manager for LiveAction. Then we're really going to hand over to the technical people within the session. We're going to look at packet capture solutions, and we're also going to look at going through that, and then finally, the most important, the heart of the matter, which is the Omnipeek overview demonstration. So with that, if we look at the next slide, I'll hand over to Peter, and I'll catch you back at the end of the session.
Mark, thank you very much for that introduction. And yeah, my name is Peter Provert. I'm the Partner Alliances Manager at LiveAction, and we're a vendor who provides the software and hardware for customers to deliver unmatched network visibility. Gartner has said that your operations teams in a customer nowadays are facing unprecedented challenges with application performance caused by a number of things, and therefore they need a complete suite of tools to be able to troubleshoot. So from using SNMP, from using flow data and packet capture data, how can we aggregate that to give that complete visibility to allow them to assess and audit the networks and troubleshoot? So the purpose of this series of webinars is to really sort of start drilling into the subtleties, the nuances, and the capabilities of what LiveAction can bring to an organization, and insofar as the various topics, be it packet capturing, be it assessments, be it reporting, be it looking at applications and quads, looking at Wi-Fi and so on. So we've already got those 3 events scheduled. We're going to be looking to do a lot more as we drill further into this. Next slide, please. And so, bearing in mind sort of the way that you're dealing with your customers today and talking with your customers as a partner and using the tool sets, think about how you can help them with all of these challenges here. And fundamentally, this is how we're driving our product development and our product adoption. And therefore, as a partner, you've got access to a complete suite of tools within the LiveAction portfolio. And to kick off with, then we're going to start with Omnipeek, and I'm going to hand over to Tony now to allow him to do the introduction and then drill in. But we really hope you enjoy it. Take it all on board. And as a former technical engineer myself, I'm really looking forward to seeing some really good insights here. So Tony, thanks very much, and I look forward to this. Cheers.
Thank you very much, Peter. So good afternoon, everyone. My name is Tony Coombs. I'm a system engineer with Nuvola. I've been in the industry for quite a few years now, with a track record with various leading, networking vendors, including working for Savius and LiveAction recently in the past. So in this session today, we're going to be looking specifically at, as we've said, the Omnipeek solution set. This is part of the packet capture element of the overall architecture that LiveAction has. LiveAction as a company has a full portfolio of application and network analytics solutions, ranging from their high-end platform, which is what we call LiveNX, which is a centralized server which provides the overall management of the network and provides, a good insight on, a good visibility on the overall performance of not just the network but also the applications running across the network in various ways. Visually, it's pretty unique in terms of displaying end-to-end flows, and it has powerful, I would say, workflows which you can very quickly drill down to isolate problems in your network or problems with applications. So it's a powerful solution. And this slide here really just shows the overall architecture of the LiveAction solution. So, we can take data sources from flow data, from NetFlow, SFlow, JFlow, practically any type of flow technology out there. Of course, we've got the packet analytics as well. This is the area we're going to be focusing on today with Omnipeek and some of the appliances that we have. But whatever the technology out there, the solution can take that in and read that in and add it to its overall view of the network to give you a good understanding of what's happening out there. And across the network, right from the edge, the branch, all the way into the cloud, through different solutions that we have there. So anyway, let's move on to the Omnipeek. I've only got a few slides. Some of you will know Omnipeek. It's been around for quite a few years now. It originally came from a company called Savius, which was acquired by LiveAction just over 2 years ago now. And Omnipeek is without doubt the premier class real-time network analyzer out there. There are other solutions out there which can do packet captures and display results, but Omnipeek is really so unique in this area in terms of the way it can actually really quickly analyze what's happening on your network and provide you with some powerful tools to fault find and debug situations that you may see. We have we can quickly, for example, identify when there's a problem on the network. Is it the application that's at fault, or is it the network? Which is a really powerful starting point for most network engineers out there. We have some really powerful expert systems. So as we're actually capturing packets, we're actually analyzing those packets and those flows, and then we're applying our expert capabilities to those in real time to isolate problems in your network. So for example, if there's voice calls running through your network and the quality is not good for some reason, we will do a MOS analysis. We will look at the packets, we'll look at quality of service and so on, and then we will highlight where we're seeing problems. And in fact, I'll show you that as a use case, how to identify voice problems on your network as part of this demonstration today. So we can take captures from Omnipeek locally. You can load it onto your laptop and you can do a local packet capture, but also we can do remote packet captures as well. So we can connect to appliances which are deployed throughout the network, and these appliances are specialized appliances which can actually do the packet capture, store the data to disk, okay, so that you can then at any time you can look at the real-time flows or sections running across the network, or you can go back in time. You can go back in time and analyze what happened last week or 2 weeks ago, because all of the packets are stored to disk. And I think the key thing about the overall solution is, like with the LiveNX solution, we have some really powerful troubleshooting workflows. So when you see something which sticks out as a potential problem, you can drill down very quickly, you can isolate those flows, and then you can start analyzing and finding out what's what's the root cause of the problem, which in the end reduces the mean time to resolution for you. So that's Omnipeek, and I'll show you a demonstration of that in a few minutes. So I mentioned that we've got some packet capture devices. These are specialized appliances out there. We have two main families. We have what we call LiveCapture, and then we have LiveWire. Both of these families are based on the same hardware, okay? And these can be deployed anywhere in the network. We have a range of appliances which start with a small desktop device all the way up into a core device which can be put into the heart of the data center and can support, for example, 100 gigabit Ethernet, so that you can capture extremely high data rates from your network. We also have virtual appliances as well. So this is a recent introduction into the portfolio. So in fact, I'll be showing you this in the demo as well. So we have a software appliance which can be deployed in VMware, in KVM, or even in the cloud, with Amazon Web Services, etc. Okay, so the two main families though are LiveCapture and LiveWire. As I mentioned, they have the same hardware capabilities, as they're based on the same platform, and both of these can capture and store packets. The difference though between LiveWire and LiveCapture is that LiveWire also has additional capabilities where we can export the flow data as NetFlow records back into LiveNX. So this gives you this centralized management capability, which allows LiveNX as a centralized management system to see what's happening across your network while you're doing packet captures in real time. Here's a typical deployment scenario. I've shown this slide many a times on my sessions. Here's a typical distributed enterprise network. You've got a data center over here. You've got maybe a campus network headquarters over here, and then you've got some remote offices. Within these networks, we've got our routers, our switches, our firewalls, and typically what you would do is you would deploy the right type of appliance in a site. So if this was a 100 gig data center network, then you would deploy probably a LiveWire Power Core, which is a high-end platform. And this would be set up to do packet captures from, in this example here, we're using packet brokers and taps, but you could use fan ports as well. There's different types of technologies you can use to copy the data to these guys. And then these guys can then be remotely managed and controlled using Omnipeek up here. And we have, as I said, we've got different appliances for different parts of the network. The Power Core for typically the data center, the LiveWire Core typically for the wide area network or the campus network. And then we have the small desktop units here, which can be used in remote offices or even home offices. I have one in my home office here, which I can show in the demonstration. Okay, and regardless of what type of appliance you've got out there, the capabilities are the same. So the software capabilities, the feature sets are the same. They have a single license model. The only difference really is performance, interface types, and how much storage data you have for the stored packets. And I have a chart towards the end of this which gives you some indication on the sizing for these devices. Anyway, that's my brief intro presentation. So I'm now going to go over to a demonstration. Okay, so hopefully you can all see these slides. This is Omnipeek. This is running locally on my laptop today. I'm actually, if I go to the start page, this is what you would see when you first load Omnipeek. You'll get excuse me, you'll get some options here to start some captures. You can look at things like look at the readmes for the release notes, all sorts of things like that. There's some sample files to get you going if you want to start experimenting with packet captures. We have some here which you can load and play with. But the key options here are really, start a new capture, open a capture file which you've already maybe stored to disk and you want to analyze at a later date, or you connect to a capture engine. Okay, I'm going to actually go to capture engines. Okay, so when I click on that, I get this display here. And on the left-hand pane here, we've got a list of all the LiveWire devices out there. Remember, the LiveWires are the capture engines. These are the devices which could be stored anywhere in the network. So these are what we call, we're doing starting remote captures. These could be anywhere where you've got IP connectivity. So I'm connecting over a VPN actually to our headquarters in both LiveAction, but also in Nuvola. And in Nuvola, we've got two capture engines. I've got my one here in my home office, and then I've got a LiveWire virtual, which is connected to our WAN links behind the firewall before the WAN router to capture flows going in and out of our headquarters. So let me connect to that. So when I connect, I'm actually connecting through a secure channel now, secure protocol between myself now and the capture engine, which is remote to me. I'm actually based in France, and I'm now connecting to our headquarters in the UK, our LiveWire in the UK. And once you connect in, then you'll see some options down here, and you can see straight away we've got some captures running. This is a LiveAction capture which is running already. I won't go into LiveAction captures today. We'll do this in our next session to explain what they are. But what I'm going to do is I'm going to simply show you how to create a capture. It's very, very simple. And it doesn't matter if you're creating a capture locally or remotely. The process is the same. You're just selecting different devices to capture from. So if I click insert, then I can give it a name. Let's say Tony's capture. Give it a comment if you like. Today's demo, right? Now I can obviously continuous capture is by default probably a good starting point. I can capture to disk if I wanted to. When I click that option there, then I'm actually now going to capture to the disk on the appliance that we're communicating with at the moment. I'm not going to do that at this point. What I am going to do is I'm going to just change the buffer size here, say 2048. This is a memory buffer, so as you capture packets, okay, initially they are stored in memory on, in the RAM on the appliance, or if you're doing this on your laptop, on your PC, okay, and then this is like a circular buffer, and then the packets are then stored from this buffer into disk, okay. So normally I set this to a sort of reasonable size, like 2048 megabytes, for example. Now, importantly, you need to select your adapter. Now, I know that this is the adapter which is connected to the LAN in our office. Okay, every adapter that you have in the appliance would be listed here. So I'll just click that one. And then there's options here like triggers. For example, I can, to start, if I wanted to, I can have a start trigger. So I can define the capture, and then I can define a start condition or trigger event. So in this case, maybe a filter, for example, and then I could say, as soon as I see a DNS packet, then start capturing. Okay, simple as that. These are all our predefined filters. We have lots of predefined filters, or you can, if you wanted to, you can create your own filter. This is rather like setting up a filter, an ACL filter. We've got a simple filter option, or we can go to advanced and really create all sorts of and or conditions. But we won't do that today. I want to really just show you what happens when we start the capture. And then down here we've got things like timestamps. We always add a timestamp to each packet file, okay, so that we can do accurate measurements. And there's different options here. I'll leave it at default, but there's other standards out there like Gigamon and Arista and Exia who have their own standards for timestamps. And then we've got the expert analysis options here. I've got these all enabled. These are really some of the key capabilities here, which allows you to do real-time analysis. So let me just start that. Let me abort that, sorry. I didn't stop the trigger. Let me go back and change that. Should have practiced this one. Let's get rid of the trigger. As it was left, it was waiting for that DNS trigger to start. So now let's just start the capture. So immediately you can see up here, we're starting to see packets. So this will increment. We've already received 208 packets. Now it's 13,000. So this is updating in real time. And now we're starting to see how Omnipeek really starts to differentiate against other packet capture solutions, because immediately in real time we can see, you know, we're starting to see different types of views here. Like, for example, this is the network view. We can see what hosts are communicating, what are the top talkers, what are the top protocols. We can go down to network applications here. We can see what are the top applications and so on. And this will just update in real time. And this is a capture of our live traffic that's running on our system back in Nuvola. So I have no idea what to expect here. So what I'm going to do is to show you some good use cases. I've already got a preloaded packet capture file, and so I'm going to switch to that, and then I'm going to run through some display options and some examples of how you can use Omnipeek to analyze what's happening on your network. So if I go to this tab here, this is a packet capture file that I loaded earlier before this session. You can see we've got, it may be hard to read here, but there's almost 250,000 packets here, nearly 24,000 flows, 15,000 IP addresses. So this is just showing you, you know, a sort of summary of what we've got in this packet capture file. And this, by the way, is just a 5-minute capture that we did on a network once. So it's running from 2245 to 2250. So 250,000 packets were captured and analyzed in 5 minutes during this capture. And we're in the network view here. Okay, so here you've got some basic stats of what's happening. This would update in real time, but at the moment it's a stored packet file. We can look at network utilization. We can zoom in if we like, and start analyzing packets there if we wanted to. We can look at things like top talkers by IP address. We can look at top talkers by country. So, when we capture the packets, Omnipeek has a capability of doing a reverse lookup on the IP addresses, and we have a database of all the country locations for IP addressing, and so we can see where are the packets coming from. So we can already see that we've got some from Philippines, Taiwan, Korea, China, etc. We change these views whichever way we like, physical addresses and so on, protocols. I can click on any of these. I clicked on HTTP. Immediately I drill down and I can now see who are all of the devices who are communicating with HTTP. So you can see details for HTTP here, each IP address, and you've got send and receive data. And at any time I can drill down further if I wanted to analyze that. So we have a network dashboard, we've got an application dashboard, similar type of views, application by flows, by top application by bytes, top applications by categories. So we also categorize the applications. So what are streaming media, what are networking protocols, what are web services, and so on. So that's another way of viewing the results. Many of these views down here, we've got application response time down here. This is giving us a great indication immediately which applications are performing well and which are not. So, you can see we've got some peaks here. I can select any of these if I wanted to. Okay, iCloud. You can't see much there, but if I change it to a logarithmic view, then you can see when the iCloud came, for example. So not much traffic really there. So one way of looking at your traffic and analyzing, giving you a good view of what's happening. Let's go to the next one, voice and video. Now this is really powerful. This is probably one of the most powerful views that we have. So if you've got voice over IP running on your network, we're going to be analyzing those flows. We're going to be applying our expert analysis to these flows, and we're going to be highlighting problems with those flows, with those voice calls. We're going to be identifying also the MOS score, the quality of the call. So we're doing real-time MOS analysis for the voice calls. Now, MOS is a standard, as we all know, and it has a scoring level from 1 through to 5, 1 being a low quality, 5 being the highest quality. And normally you would want most voice calls to be above 3.5 MOS to be of decent quality. So here we've got a good summary of those voice calls as they occurred. We've got some basic call counters and call stats here. You can see over here that this is actually real time. I'm back on the real time display again. This is actually our live network. So you can see we've got some voice calls running in real time on our live network. Let me click back to the stored one, this one here. This is the one that we loaded earlier. So this is the packet file I loaded earlier. Look at this here. Over here, we've got call quality distribution. So around about 2/3 of the traffic, the voice calls are good. but around about 30% are bad. So this is a good indication that there's something seriously wrong with voice calls running over your network. And you can see at this chart here, this timeline here, that shows when we're getting good and bad calls. We've got the codecs down here. Let me click on this codec here, G711A law. Let me do it down here as well. So you can see for this particular codec, when we started off with a MOS score of 4, and very quickly it fell down to 1, which is really the lowest quality. And you can see the call volume is actually also quite low as well. So this needs investigating. So I'll come back to this in a little while to see how we can debug this, okay, to analyze what's the root cause of this. Let's try and find a solution to this problem here. But in the meantime, I'll just run you through some of these, and then we'll go into some of these use cases. So Compass, Compass is another dashboard we have. Very interactive, this dashboard. We can, at the moment, we're looking at the overall throughput in megabits per second for that packet capture. I can change it to response time. So this display will change, and now we're getting an indication of the response time over that packet capture period for all of the applications. Notice here, down here, this display has changed, and you can see all of the IP hosts, their MAC address, and their response time. Now, response time, what does response time mean? Response time is what we calculate as the total of the network plus the application server response time. So this is what users would experience, okay? If we wanted to, we can break this down to network and application response time. And this is where we can start identifying, you know, is the network causing a problem, or are applications causing a problem on your network? So I change this display. I go to two-way latency. Now we've got the charts changed, and you can see there's some really big peaks. For blue is application response time. Green is network response time. If I take that off, switch off application, you can see predominantly, apart from this period here, we've had some pretty good network response time. It's not been bad. So immediately we've identified, you know, that network seems to be performing okay. It's the application response time which seemed to be a problem. So this has given us clues already that things need to be investigated. Now, if I wanted to, if I open up this area here, for example, okay, I can expand it out. And if I wanted to, I can now right-click, sorry, not right-click, I can do select related, and I can do this. I've got to do it right. My mouse is out of control. Oh, my mouse, oh, there we go. It wasn't clicking correctly. So what I did there, I selected a period of time, okay? Then, and that period could be a period where, you know, there was a peak in response time or some other thing that I thought was interesting. And then I've now got this option here where I can pull all of those packets that I've captured, and I can store them into separate tab for analysis. So if I do that, copy selected packets, I then go over to a new tab. I can rename this. It's normally good to rename these. That's Tony's selection, for example. And now in Compass, and also for all these other applications, including voice, you can see we've filtered down, we've created what we call display filters, and we've filtered the traffic down to a specific time period for further analysis. And this is an example of how you use Omnipeek to drill down to identify problems in your network. Okay, and I won't go any further with this at the moment because I'll close this because I'm going to use that technique in a couple of use cases I have in a few minutes to show you. So of course we can look at the packets. These are all the packets. We can do a real-time decode. Okay, these are all the packets that we've identified. Notice when you click on one, it highlights the next packet in the series for that particular session. We can change this view up here on the different display options here. Let's add size bar. So now I've added a size bar so I can see the breakdown of the packet formats. So you can see, you know, Ethernet type, IP, UDP, and the protocols, and you can see overall size of the packet. So that's something I tend to add if I'm looking at performance issues, for example. And we can just drill down and you can see how this builds up. Okay. If you see a particular flow or packet of interest, you can actually do a create a filter based on that particular packet format. So you can see the source address, destination address, they've all already been pre-filled here. You've got the port types, destination port types, and the fields, etc. And then you can create this as a filter and save it. Okay, if I wanted to, but I won't do that. Okay. We've got events. I'll come back to these in a little while. We've got all the client servers, expert analysis. So this is a breakdown of every single client on the network and who they're communicating with. Okay. So and when you open these up, you can see, for example, what protocol they're using. Notice down here, we've got event summary. We've got HTTP slow packet response time. If I click on that, then it highlights which of these flows have got slow response time. So if I want to analyze that further, select related packets, find a flow, and then we're actually reading the packet memory, and we're moving all of those packets associated with that particular flow where we had a performance issue here, slow response time, and now in a different window. So we can now look at the packets. We've got rid of all the noise that we don't want to see, and we can start analyzing if we wanted to. So another good example of how you can use selected packets to drive down. What else can we do? Peer map. I'll come back to some of these in our examples here. Peer map. This is a graphical view of all the conversations that we've seen in that packet capture. Actually, we're only showing the top 100 here. If I go to that, the top 1,000, you can see how many flows we've tracked and we've analyzed, and we've matched the relationship between the different devices. So that's an enormous amount of data there. So that's a bit too difficult to analyze. So let's go back to a smaller view. Let's look at the top 100. Okay. Arrange the nodes. Now, if you click on any of these nodes, you can see, as you move around, you can see what some basic stats information about that node, what protocols they're using. Okay. We can go on to the actual links as well. Okay. When they are multicolored, these links, like here, there's 2 different colors. I don't know if you can see. That's because there's 2 different protocols in use. Haven't got a good example of that there, but we will see some later. So I can look at this from an IP perspective, from an IPv6 perspective. Oh, there's no IPv6. From a physical perspective, just 2 devices involved in this. So these must be routers. Go back to IP again. We can switch on and off protocols down here. So down here we've got a display of all the protocols. Try and make this window a little bit bigger. You can individually switch these on and off, or I can turn them all off. And then we can just go through the list and say, well, what are we looking for? Let's look for, I don't know, Telnet. So I clicked on Telnet. Someone's using Telnet in this network. Let's right click on it. Let's look at the packets. Source and destination. Pop it into another tab. And then you've got all the flows, all the data related with that customer, and you can go down and you can actually analyze that if you wanted to. There's the Telnet side down there. So we've captured every single, for that particular connection between the 2 devices, we've actually connected not just Telnet, but also everything else. But again, I can drill down further if I wanted to. So can I do it here? Not here, but I can do it other places like here, for example. And just right click, and I could, where is it? Telnet here. I can start analyzing from here as well. So that's another way of drilling down. Back to the peer map. Any of these nodes, by the way, you can, they're showing the IP addresses. We can actually add, if you know what the name of the host is, you can add them to the, you can resolve the name, or you can manually add them into the name table if you like as well. Switch these all back on again. Now, let me show you one other aspect, countries. So remember earlier on, I mentioned that we can do a lookup on the source IP addresses for all of the IP addresses that we see during the capture. And you can see here that we've got most of the traffic's up here with UK, France. Oh, we're back on the LiveWire one again. Let me go here. But I'll kill that one. Because I'm going to stay with this guy. If we go here, we can see in this packet capture, we've got, packets from UK. Most of them are in the private network, but there's some here from, for example, China. And you may wonder, well, who is doing what? Who's connecting from China into our network? That could be a security issue. So let's select that by source destination country, move it over to a new tab. Let's rename this China. Oops, can't spell. Okay, so that's our China. Let's go to peer map. Ah, this is interesting. Here we've got, it seems that a single host is communicating with multiple hosts in our private network. These are all our private network addresses. Okay. And then this host here is trying to do, I don't know if you guys can see this, but you can see he's trying to make CIFS connections to all of these hosts. Now notice that the dot on the end of these lines, which is not dark like here, it's light. And the reason for that is because the TCP connection has not been established. So what this is telling me is this host here is trying to make CIFS connections to all of these hosts. So it's probably, and CIFS, by the way, is a file transfer application protocol from Microsoft. So this looks very suspicious to me. This looks like this guy's trying to make connections, and then if he doesn't succeed, then he has here, for example, you can see he's made a connection here because it's dark. He's trying to maybe do file transfers. He's maybe trying to pull data from these hosts. If we go back to flows or client server, it doesn't really matter. Look at the expert analysis down here. This just confirms what I suspected. TCP repeated connection attempts. So this host is definitely doing some sort of scan on the network, maybe a port scan, trying to hack into systems to do some security attempts. Okay, let's go back to here. Right, I'm going to show you a couple of use cases. Okay, and the first one is I'm going to show you how to analyze voice calls. Okay, so remember we've got this display here. This shows you an overview of all the voice calls running on the network, and we've already seen that G711A codec has got some pretty dire quality issues. There's something going on there. Okay, so we need to analyze that. So what I'm going to do is I'm going to go down to this section down here, voice video. I'm going to look at the calls. So we've now got a breakdown, a list of every single voice call that we've captured. Okay, so there's 52 calls in this capture session. Down here we've still got our expert analysis, and if you look here, voice over IP, we've got RTP late packet arrival. And when I click on that, you can see the sessions where we're having this problem. Now, what is a late packet arrival? If you don't know, click on that, look at the settings, then you'll get here a summary of what it is, a description of it. RTP, within a voice call, there's two main protocols. There's SIP and there's RTP. SIP is really the control protocol for, setting up, establishing, and tearing down a call. Okay. RTP is the transport protocol for sending the voice data over IP. So this is where you know, the conversation, the voice conversation flows. And if you're getting an RTP late packet arrival, what this normally means is that you've got latency, you've probably got jitter, but also the packets are not arriving in sequence fast enough. And it says here, for example, if a packet doesn't arrive within 30 milliseconds from the previous packet, then you're going to start having problems. So whenever we measure those RTP packets, if we see a packet arrive after 30 milliseconds, then we're going to flag it as a late packet arrival, okay, to give you an indication of the problem. So you've got a description here, you've got a cause. It could, you know, it's saying it could be, you know, your network, it could be your links, could be congested, it could be your routers or your switches, it could be, you know, anything within the network which is causing the problem. And then it gives you some, you know, potential solutions here, you know, that you want to apply. One of those is, of course, applying quality of service. And normally for voice, you would normally, with IP quality of service, you know, did serve code point, you would normally set it to EF class, which is the best class for low latency interactive traffic like voice. Okay. So anyway, so we've got these late packet arrivals. When I click on it, I can see that this particular call from extension 104 to 103 is one of the sections affected. Let me select that and pop it into a new tab. Okay, it's up here. Let me rename it so I don't get confused. Okay. Right, so immediately we've got the packet decodes down here. So you can see, you know, we've got what I was explaining earlier, you've got the SIP packets, and then you've got the G711 packets. This is the codec that's used within RTP. And if we go to voice video now, we're only going to see a view for that call. So we've filtered out all of the other voice calls at this time. And you can see at the beginning, we had a good quality, it then got bad, and then it just got to extremely bad. Okay, and you can see this is the MOST analysis over time, 4, and it went down to 1. Okay, so definitely a bad call. 100% of this call is pretty much bad. So let's analyze it further. So let's go down here to calls again. Look at the call. Now, it could be the signaling that's gone wrong. The SIP signaling has gone wrong. I doubt it. Or it could be the quality of the packets coming, you know, the RTP late arrival, which seems to be the issue. But if you're not sure, you can right click on here. You can look at video voice flow visualizer, and then you get a indication here of the signaling. So this is showing you the SIP signaling, and I'm not a particularly good expert on SIP, but it looks all okay to me. It started okay and it finished okay. In between, we've got the actual, this is the call, and you can see some basic information here on the quality of the call. Let's go to this other tab, which expands it out a bit. Here you can see 2 graphs. We've got one at the top here for jitter. So high amounts of jitter, very high amounts of jitter. in fact. And as we've seen it earlier, this is the quality again. So you can see we've gone from almost perfect down to poor quality within seconds. Okay, so there's definitely something wrong with this call. How do we drill down to isolate it further? So if we go to this option here, media, actually, before we do that, let me just show you this. We can actually play the audio. So if I click on that, we will actually reconstruct the call into a WAV file. And if I play this.
Hello, this is Joe. Hi, Joe. This is Jim. I'm doing a test call from a SIP phone to a skinny phone, which.
So you can see that we've reconstructed the voice call and put it into a WAV file, and then we can play it back if we wanted to. So we can actually also hear the quality as well. Okay, hear what the people, the quality of the call is. Now, we can't do that with all codecs. Some codecs are very proprietary, some codecs are encrypted, but the ones which we can decode, you can actually play back those calls. And if you go to our website, by the way, there's a whole list of codecs that we support for playing back the calls. But go back down to media. Now, what is media? Media is actually the unidirectional flows for the calls. So we've got the call being broken, the telephone conversation being broken down into both directions, from client A to client B in one direction and client B to A in the other direction. And again, we can do flow visualizer, we can play the audio in one direction. Let's play in one direction just to show you that it works.
Hey Joe, this is Jim. I'm doing a test call from a SIP phone to a skinny phone, which you should be on. And how does it sound?
So
wonderful.
So notice that we're just seeing one direction of the call. Okay, so you just to show you we've got two directions. Now notice here that we've actually got the ditto code point here. In one direction, it's set for EF, expedited forwarding. That's the correct class of service for the call. But look in the other direction, default. In other words, there's no class of service. So that means in one direction, from client B back to client A, there was no class of service set up on the IP packets. So that's pretty much indicated to me the root cause of the problem here, because in one direction we're not providing quality of service. We can't, because the network can't do that, because it can't analyze the packets. It can't see the ditto code points and put those packets into the appropriate egress queue on the routers and the switches. And so those packets are being queued in a default queue behind everything else. And so there could be file transfers, there could be web browsing, there could be all sorts of traffic in the default queue, which is getting in front of the voice over IP packets, and hence causing delay, hence causing the RTP delay beyond 30 milliseconds. That's why the quality of this call is bad. Okay, so that's a good example of very quickly identifying voice calls, seeing from a high level what calls are good, what calls are bad, drilling down, looking at the expert events, seeing those events, highlighting which individual calls are affected, and then selecting those calls and then doing analysis. And this could save literally hours and hours, or even days of fault finding if you didn't have a tool like this. on your network. So let's do one other. Okay, how are we for time? Okay, we'll do one more use case, and then we'll go over to Q&A. So I'm back on Compass, okay, which is this interactive view. Remember, we've got, you know, response time. We can change the view to response time. You can see that there's some calls here with extremely high response time, 127 seconds. So remember, response time, what we mean by response time is equivalent to the user's experience on the network. Okay, we can break it down to two-way. So we can separate the network latency from the app latency. So what is the difference? What is network latency? So network latency is, what we're doing is we're looking at the TCP connections. We're looking at the SYN, the SYNACTs, and we're measuring the response of those for the sessions. And this gives us a good indication of the response time for the network. And then above that, we're looking at the application response time. So when, for example, a client put in a HTTP request, how long did that take for that request to come back minus the network response time? So that's how we calculate these things. And we can see quite a few applications here. These two here have very high latency, application latency. So let's click on that. Okay. Now see here, let me just unclick because maybe you didn't see that beforehand. At the moment, we're showing app response time, which we can switch on and off, network response time, which we can switch on and off. But let's add this session here, this IP address here. Now we've got some more here. We've actually moved this as a clickable object within this display here. So I can get rid of application, I can get rid of network. And now we're just looking at that particular application. And now what I can do is I can select those packets. Okay, my mouse is a bit, here we go. Copy those packets over. So if we go to flows, look, we're getting slow server response time. Okay. Now what I can do, I can now, in a similar manner to what we did with voice analysis, I can, when I click on these, I can, well, we can see it's SQL. We can click on any of these and I can do a flow visualizer. And now we've got a breakdown of the session for that particular flow. We've got the client server. This is a ladder diagram showing you the TCP protocol behavior. Okay, and you can see from the client and server, when the client sends a packet, when do we get a response? And we've got a time frame window here. I've got it set to 1 second at the moment, but I can change it if I wanted to. Along here, we've got slow server response time. So clearly what happened here is, at this point here, at packet 303, we obviously issued a SQL command. Then we've got nearly 4 or 5 seconds before we get the response. So the command was issued there. We get a NAC. This indicates a NAC. I can open these up if I want to, make them wider if we need to. But you've got this the acknowledgement to that request directly, almost immediately, but it's taken almost 5 seconds before we get the packet, and it's packet 4483. Now we can actually decode those packets, and we can go down, and as we go through, we can see the actual SQL commands. So, for example, this is packet 293. Where were we? We were here. That was command 303. So, be down here somewhere. Down here somewhere. You know, you find the packet. Let's say it's this one. There it is, 303. That's the actual command that was sent in that request. And then 5 seconds later, we get this response here, 483. So what you can do is you can just say, well, obviously this is an application response issue, not a network issue. There may be something wrong with this SQL query. So let's right click on that. Let's put a note on that and just say potential SQL query. I can't spell. Still can't spell. Potential SQL QUEIE. There we go. There we go. You get the point. Packet. Okay, click that. Okay. Now what that's done is we've actually put a note into our packet capture file, and then we can go back, and at any time we can go to net. We can see that, and we can go directly to the packet. There's the packet. And then if I wanted to, I can save that packet. Where's the packet? It's this one here. I can save it. Save selected packet, and then I can, you know, SQL issue together with the note and obviously the contents, so that could be sent to the department, the application team, which looks after the SQL server, and then they can look. You've got that command. They can then research that to see what was the cause of that particular problem. Okay, how are we for time? Okay, I think pretty much.
Tony, yeah, we've got loads of questions.
Have you? Okay.
It might be worth. I mean, to be honest, it might be worth just going through those whilst you've got the demo up, going through some of those questions. You can see those, can't you?
Can I see the questions? Let me just look. Where would they be?
On the right-hand side, on the control bar.
No.
If not, I can read them out. Yeah.
Yeah. Okay. No, sorry, I can't see the questions.
I can't see the questions now.
It's in chat.
No, there should be. Oh, the questions gone. I was just going through the questions. Here we go. Here we go. So, what are the questions? LiveWire Virtual, does it work with Hyper-V?
Yes. Yes, it does.
Okay. Actions on triggers. Can you create triggers based on search string regex?
A search string. You can. I'd have to think about how to do that, but I'll look into that and I'll put that in an FAQ afterwards. But
okay.
Yes, you can.
When the capture is triggered by hitting the defined filter, is it going to capture? And I need to open this a bit more. Is it going to capture only traffic defined by a filter?
Well, the trigger, it depends on how you do this. If you just set up a trigger, okay, let's say you're looking for, I don't know, DNS packets, right? If you do a trigger to start a capture on when you see a DNS packet, if you haven't defined a filter also, then we will capture every single packet, okay? But so what you want to do is you want to do, if you're just interested in, you know, DNS, so, or any other protocol or application, you define a trigger for that protocol, but you've also define a you'll also define a filter for that. So let me show you that here, really easy. So for example, if I do a new capture on my machine here, oops, I don't want to do it there. Let's do it on, because I have to restart. Let's go to capture engines. Let's insert new capture. Let's define the adapter here. Let's do trigger. We're going to do a trigger event. We're going to do it on DNS, for example. Okay. But then also we want to do a filter. And we want to do a filter on DNS as well. Okay. And it's as simple as that. So we've now got a trigger set up on, in this case, on LiveWire virtual running in machine. And there you go. Right. Someone's done the DNS request, or something's done the DNS request. So it's started the packet capture, but then also we've got a filter to only capture the DNS packets. So it's really super simple. Okay. You know, it took me what, 4 or 5 seconds to do that. And then this will just carry on now. These are the DNS packets. You know, just seeing DNS, you've got the analysis of just DNS on the packet, and you've got all the other features. You look at the peer map, who's sending out the DNS requests. We're going to Google. That's the 8888, that's the DNS server for Google. Okay, so I could just leave that running and then we can see that filling up. Okay.
Okay, so what volume can be processed? 10, 40, 100 gig a second?
What is that, sorry?
Up to what volume can be processed?
Oh, right, okay, so it depends on the appliance. Okay, so they all, in fact, I've got this chart here. I was waiting for this. Okay, so then we put this chart up here. Right, so these are all the capture appliances out there. So we've got the LiveWires, okay, and then we've got the LiveCaptures. Okay, now the LiveWires and the LiveCaptures, they all do packet capture. Okay, they all do packet capture exactly the same way. Okay, the difference is that the LiveWires also export to IPFix. In other words, NetFlow. So those packet captures are then being, as we capture the packets, we're then exporting that capture information as NetFlow records into LiveNX or any other NetFlow collector. But we, of course, we prefer LiveNX. Now, in terms of performance, you can have different types of interfaces in these. This guy is fixed. It's just 1 gig. These ones here can support, and these ones here can support 1 gig, 10 gig, and 40 gig interfaces. But the core, the power core and the 3100 can also support 100 gig interfaces. And you can see here the overall performance. So up to 40 gigabits per second capture rate. So on a 100 gig interface, we can capture constantly at 40 gigabits per second using what we would call an internet mix of traffic, which is a mix of between, low end, small 64 byte packets all the way up to 1500 byte packets in a typical internet mix. Okay, so obviously, you're not going to be able to capture line rate at 100 gig We are working on all the time to improve that performance, and we've got some tricks coming down the line which will improve that performance as well even further. But normally what we would do is, you know, in those environments where you've got 100 gig or you've got 40 gig or even 10 gig, you would normally have packet brokers out there which would be there to you know, direct the traffic from the network to the appliance, and in many cases the packet brokers would pre-filter to only allow certain traffic through that you want to capture. Thank you guys, take care, bye bye.